Hello engineers, welcome to the new video of the course, and in this particular video we are going to redraw the block diagram, or basically we are going to redefine our block diagram which we drew a few sessions back when we were dealing with the basic block diagram of our project, right? So before coming to this particular point, we will quickly revise that what all things we saw in the previous session. So in the previous session we understood the concept of sensor, and specifically we understood the working of LM35 in depth, right? So what exactly it is doing, it is just taking the temperature and then it is converting into some electrical quantity, and that is my volts, right? But the important thing to notice over here is this, that is sensitivity. The sensitivity of this particular sensor is 10 millivolts per degree change in temperature. Then what does that means? That means if my temperature increases by 1 degree Celsius, okay, from 0, right, from 0 to 1 degree Celsius, right, then the sensor provides 10 millivolts at the output, right? Similarly, if the surrounding temperature is 10 degrees Celsius, then my sensor will provide around 100 millivolts at the output side. Okay, now the point to notice over here is this, that is millivolts, right? Now the thing is that the sensor is providing me some analog voltage, okay, and when it comes to controllers and processors, then it becomes difficult for them to identify the analog voltage, and even if they did, then the another task for them, the another issue or the task that they may face is to store this particular voltage, because as you all guys know that we cannot store the analog voltage. So this analog voltage, it needs to be converted into digital format. Okay, so let me proceed further, and you see over here microcontroller cannot process the analog data which comes from the sensors, right? Why? Because to process the data you first need to store the data, right? You just need to analyze that particular data and then perform certain activities or certain actions on that particular data. Okay, this analog data needs to be converted into digital form, which can be further easily processed by the microcontroller, right? So we need a system which can convert this particular analog signal to digital signal. Okay, so it's my request to you all guys that you please pause this video over here and try to think that what that particular system can be. Okay, it's my request to you that you please pause this video over here and try to think in your mind. Alright, I believe that you all guys have tried your best. Now it's my turn to elaborate it, or to give you the idea about this particular system. So the name of this system is ADC. Okay, name of this particular system is ADC, analog to digital converter. So that means you are getting some analog voltage over here. You see over here we will get certain analog voltage. Okay, so this is my V of analog voltage, V analog. Okay, obviously it will be in millivolts, so whatever the voltage that the sensor will provide, it will be in millivolts. Let's suppose 100 millivolts, and that defines that the sensor is getting around 10 degrees Celsius at its input, right? So that's why it is providing 100 millivolts at the output side. Okay, so this 100 millivolts, it needs to be converted into some digital data. Okay, and that data is being converted by this particular system, that is ADC. So basically, instead of taking 100 millivolts, now this ADC will give certain digital data. I'm just writing a rough value 1 0 0 1, something like that. Okay, 1s and 0. So basically, this ADC will provide 1s and 0s at its output side. So now it is pretty easier to store this 1s and 0s. Okay, we can easily store this 1s and 0s. Okay, and after storing that, we can actually process this particular data, and that is the task of controller, right? Okay, so I hope you understood this particular concept of ADC. What is the task of ADC? Task of ADC is to just convert the analog data which it is getting at its input side from the sensor, and then to convert this analog data into digital format. Okay, now we need to redefine this particular block diagram which we had seen in the previous few sessions back, right? What we saw, let me just give you a rough idea what we saw in the block diagram session. So we saw that there was one sensor, right? There was one sensor. Okay, the output of this sensor is connected to some microcontroller, and then the microcontroller was displaying the data to the LCD, right? Was displaying certain data to the LCD. So this was the rough block diagram which we drew when we started this particular project, right? Now we need to elaborate this particular block diagram. Okay, we need to elaborate this particular block diagram. So you will get input to the microcontroller from the sensor. So the temperature, let's suppose it is 10 degrees Celsius, right? So now you know that the sensor will provide 100 millivolts at its output side. Okay, the microcontroller will store this particular data, and now this microcontroller obviously it is going to give some hex codes to LCD, and this LCD now it should display 10 degrees Celsius. Okay, it should not display this 100 millivolts, right? Okay, it should display me 10 degrees Celsius. So that is my task. Okay, so now let's redefine this particular block diagram. So this is how it will look. So now you see over here that the sensor, it is getting 10 degrees Celsius, right? It is sensing 10 degrees Celsius. Now this 10 degrees Celsius, it will be converted to 100 millivolts for sure, because the sensitivity is how much? 10 millivolts per degree change in temperature. So you will get 100 millivolts over here. Now as I had clearly mentioned that we cannot store this analog data, right? We need to convert this analog data into the digital format. So that is done with the help of this ADC. So 100 millivolts will be converted into some digital data. So let's suppose that particular data is 111, right? Because as I had clearly mentioned, if you could remember, the ADC present in ATmega32, it is of 10 bit. Okay, so ADC in ATmega32, and in fact in Arduino as well, it is of 10 bit in size. It is of 10 bit in size. Okay, so now you will get 10 different logics. So 1 0 0 1, something like that, 0 1 1 0, something like that. So 1 2 3 4 5 6 7 8 9 and 10. So you will get 10 such data, right? 1 2 and so on, 3 4 5 6 7 8 9 and 10. So you will get 10 such bits. Okay, I mean the equivalent of 100 millivolts will be this one, right? 10 bits. Now we don't know what that value is. It's not required as of now. We just you just need to understand it in the basic format, so that it will actually help us to design the program and the logic properly, right? So basically this 100 millivolts will be converted into some 10 bits of data. Okay, now when I say that it is converted into 10 bits of data, so obviously it will be held by certain register. Okay, so this particular value, let's suppose it is X. We don't know what that particular value is. I mean this 10 bit data, let's suppose this 10 bit data is X. So this X which is converted over here, so this 100 millivolts got converted into X, right? X is nothing but a 10 bit data. This X has 10 bit data over here. It has 10 bit of data in it. So this data, obviously it needs to be stored in some register, right? As I clearly mentioned, what is the task of register? The task of register is to hold the data. So inside the microcontroller, there is some register. Now we don't know what that particular register is. Don't worry, we are going to see that as well. Okay, but the basic task is to hold this particular data, right? And after that, you see, we cannot display 100 millivolts over here. So this data, this 10 bit data, right, which is stored in this particular register, it needs to be converted, and then you need to display over here as 10 degrees Celsius. So this will be the modified block diagram of our project. Okay, and this will be the final block diagram of our project. See, again I'll just repeat what all things we saw. At first we saw the concept of sensor. The task of sensor is to convert the analog data into the the task of sensor is to convert the temperature or the physical quantity into the electrical quantity. In our case, the LM35 sensor that we are using, it is converting this 10 degrees Celsius into 100 millivolts, right? So basically it is converting the temperature into voltage. Now microcontroller cannot process the analog signal because it needs to be stored, and as we know that analog signal can't be stored. So basically we take ADCs which are readily available in case of ATmega32. So the task of ADC is to convert this analog data into the digital format. So you see this particular analog data, 100 millivolts, it will be converted into 10 bit of data, right? Okay, so these are the random values. It's not necessary that you will get like these values only. I'm just taking this as 10 bits. Okay, so let's suppose this 10 bits is being held by this particular variable, that is X. So now this particular X, it needs to this 10 bit of data, it needs to be stored at certain register, in certain register, right? So again, we don't know the name of the register. I'm going to reveal that name in the upcoming session, so don't worry about that. Okay, so this X is being held by this particular register, and after that you need to again convert this 10 bit of data into the readable format, that is 10 degrees Celsius. So this will be the entire working or the block diagram of our project. Okay. But before coming to the programming part, just remember, like whenever you deal with embedded system, before designing the software or the programming part, you first need to understand the hardware stuff. Okay, because without understanding the connection of certain components or maybe certain output or input system, you cannot design the entire code, right? So it becomes pretty important for us to understand the interfacing the hardware kind of stuff, right? So you see over here, this is my ATmega 32 microcontroller. Okay, you see this is my LCD, and you see this is my LM35 sensor. So you see over here, this is my sensor LM35. As I had already said, as I have already said that we need to connect this sensor to the ADC channel, and you see this is my ADC channel, ADC0. So I'm just connecting it to this ADC0 channel, or basically the pin number 0 of port A. Okay, this is my sensor. I hope you all guys know the pinouts of LM35, which we had already discussed in our previous session, and also we had seen the working and its sensitivity and all, right? I hope you all guys remember that. If not, it's my request to you all guys that you please return back to those videos, just visit back to those videos and just recollect all of those points which we had discussed in that particular video. So you see over here, this is the pin number 1, it is my VCC. Okay, this is my Vout pin, the pin number 2, this is my Vout pin, and then the last one, that is pin number 3, this is my ground pin. Okay, this is my ground pin. Okay, so you see that whatever the output this particular sensor is giving, we have connected this output pin to the pin number 0 of port A, pin 0 of port A. Okay, I hope this particular part is crystal clear. And over here I have just connected the voltmeter. I'll explain you that why exactly I have connected this voltmeter over here, so don't worry about that. And then you see this is my LCD. I have connected the data pins of LCD, that is from D0 to D7 to port C. So this is my port C. Okay, port C. Okay, and if you could remember in the previous session, like when we saw the interfacing of LCD with ATmega 32, over there as well the connection was same, right? It was similar. I have not changed anything. So you see the data pins are connected to port C, and then we have these 3 pins, that is RS, RW and enable. We have connected it to pin number 5, 6 and 7 of port D. So this is my port D. Okay, and to pin number 5, 6 and 7 we have connected this RS, RW and enable pin, and then VSS is grounded, VDD and VE we have connected it to 5 volts. This ARF and AVCC we have connected it to 5 volts, so don't worry. I'll explain this as well when we proceed further, so don't worry about this one. Okay, so this was the hardware part. Okay, I hope that you understood that how exactly we have connected the input and the output system. The input system was sensor, we have connected it to pin number 0 of port A. The output system is our LCD, through which we are going to display the output or the data that we want to show. Okay, we have connected the data pins to port C and RS, RW and enable pin. So basically these are like the controlling pin of our LCD, and that we have connected to pin 5, 6 and 7 of port D. And then I hope you guys know the function of VE and VDD. V is like LCD contrast, through which you can control the green light of LCD and all, which we had already discussed, so I will not discuss that part over here. So this was all about the hardware stuff or the hardware part. I believe that you understood the hardware part. Okay, modify that. So I'll just ask my controller to again give back the data to the first row, first column of LCD, that is 0x80. Okay, and let me again run it, and yeah, it is not giving any warning. And you see right now the time is 11:58. So let's quickly burn. First of all, we need to pause it and let's quickly burn the updated code. So yeah, you see the timing is 11:58, approximately 5th of October 2024. Just click on open, and I'll just click on OK, and then I'll just run it. Alright, you see temperature, and beneath it you will be getting 25 degrees Celsius. One sec, there is some issue with my mouse, so that's why not able to zoom it out properly, but I hope you are able to see this. Yeah, you see one sec. Yeah, you see it is 25 degrees Celsius. Okay, now let's suppose if I want to show 5 degree or 8 degrees Celsius, let's suppose my temperature is below 10 degrees Celsius. Let's see what we are getting. 7 degrees Celsius, let's say. So yeah, you see it is trying to match with this particular sensor's value. Yeah, you see it is 007 degrees Celsius, right? Now let's suppose the temperature is, or the sensor is sensing, let's suppose above 100 degrees Celsius. Let's see what happens. So as you can see over here, you see 22 degrees Celsius and we are getting 222 millivolts. Because why? Because the sensitivity of the sensor is 10 millivolts per degree Celsius. So 22 into 10, that is approximately 220, right? And that's what we are getting, 220 millivolts. Okay, and that's why I had intentionally attached the voltmeter over here, just to show that the sensor or the sensitivity of the sensor is around 10 millivolts per degree rise in temperature. Okay, so this is how you have to observe the things out over here, and I hope that you are able to understand the entire thing that we have studied right from the starting, right? So now let me erase the temperature. Yeah, let's say if I want to show 102 degrees Celsius. Okay, so you see over here it is 102 degrees Celsius. The sensor is sensing 102 degrees Celsius, and yeah, you see onto the LCD we are able to get 102 degrees Celsius, right? Okay, I hope you are able to understand this, right? I hope you are able to understand this. 96 degrees Celsius, and yeah, it will update. It will take some time. It will take few seconds. Yeah, you see 96 degrees Celsius. Let's say 90, from 90 I'm going back again to somewhere around 52, 51 degrees Celsius. So it should be able to show 51 degrees Celsius. Yeah, it is showing that. So with this we have actually completed the entire project. Okay,